Everything you see feels solid, stable, predictable. But what if none of it truly is? What if the reality you experience every day is only an illusion created by your senses? For centuries, physics described the universe as a giant machine. Every object had a position. Every motion had a cause. Reality was solid, measurable, and deterministic. This view of the universe worked perfectly until scientists began to look closer, much closer. At the smallest scales of existence, reality no longer behaves the way we expect. And that discovery would change our understanding of the universe forever. For centuries, scientists believed the universe followed strict and predictable rules. Every event had a cause. Every motion could be calculated. If you knew the exact position and speed of every particle in the universe, you could, in theory, predict the future perfectly. This idea was comforting. It suggested that reality was stable, reliable, and understandable. The universe was seen as a giant clock, a perfectly synchronized machine, ticking forward through time. But this elegant picture had a flaw. It only worked until scientists began to look at reality on its smallest possible scale. When scientists zoomed deeper into matter, they expected to find smaller pieces of solid substance. Instead, they found something deeply unsettling. Particles behaved like waves. Electrons could spread out across space, interfere with themselves, and exist in places they were never supposed to be. Matter refused to behave like matter. It refused to choose a single identity. At the quantum level, reality stopped making intuitive sense. Quantum physics revealed something even stranger. Particles don't exist in one state at a time. They exist in all possible states. Simultaneously, a particle can be here and there, moving and still, existing and not existing. Reality becomes a cloud of probabilities, waiting for something to force a decision. At this level, certainty disappears. Only possibility remains. So what forces reality to choose? Observation. The moment we measure a quantum system, its many possibilities collapse into a single outcome. This means observation doesn't just reveal reality, it changes it. The universe behaves differently when it is being watched. And that idea shakes the foundation of science itself. Even empty space isn't truly empty. At the quantum level, space is unstable. Particles appear from nothing and vanish back into nothing. Energy fluctuates constantly. The vacuum is alive. What we call nothing is actually a seething ocean of activity. Some theories suggest that space and time themselves are not smooth. Instead, reality may be built from tiny indivisible units, like pixels forming an image. Below a certain scale, the concepts of distance and duration may lose meaning entirely. Reality may have a resolution limit. Quantum mechanics governs the small. General relativity governs the large. Both theories work perfectly until they meet. When gravity and quantum physics collide, the equations break down. Our best descriptions of reality refuse to cooperate, and physics hits a wall. To overcome this, physicists propose bold ideas: extra dimensions hidden from perception, vibrating strings forming the fabric of reality, entire universes beyond our own. These ideas may sound extreme, but so did quantum physics a century ago. Reality may not be solid, it may not be objective. At its deepest level, the universe appears uncertain, probabilistic, and mysterious. And if reality itself is unstable, what does that say about us? Perhaps understanding the universe means redefining what it means to exist. If reality is built from probabilities, if observation helps shape what exists, then one final question becomes impossible to ignore. What if reality itself is being observed? And what if our universe is not fundamental at all? If you enjoyed the video content, don't forget to like and subscribe, and let the information come to you. Welcome to Nucleus Science, where we explore the core of reality.